Today we will have an overview about the concept of the wave function. The wave function is the central unit of quantum mechanics. So every system, every particle, every molecule will have a wave function. The wave function contains everything that we can possibly know about the system, and then we have to be able to use and manipulate the wave function to extract all the information we need. So now, what are the central elements of the wave function? Well, it's basically a function. So it's just, if you now think in terms of just a one-dimensional system, the wave function is a simple function. So it's just like saying we take the value of the function in a given point, and that's going to be our wave function. Nothing more complicated than that. The x here is simply the position of the particle. So if this is just a position of our particle, whereas the value of psi defines the amplitude of the wave function. So this behaves exactly like a normal wave. So like a wave, we can add two different waves to obtain the third wave. So we can always take a third wave obtained as a combination of wave number 1 and wave number 2. Okay, so the amplitudes will add up. The difference between a classical wave and a wave function is the way we interpret its value. In a normal wave, the amplitude of a wave is already a physical quantity that we can measure. This is not the case for a wave function. The way we interpret the wave function, the standard way of interpreting the wave function, say that, okay, if we take the square of this amplitude, so if you take the wave function squared, then we get another function, which I'll try to draw here based on how the other one looked like. So it would be like this, and then it goes to 0, so it just goes up again, and then like this. So this would be the previous function squared, so psi squared of x. Okay, so we interpret that saying that this is like proportional to the probability of finding the particle in a given position. What does it mean? Well, it means that if we look at this function, this particle will be very likely localized in the red zones here, so in this position here, and in this position here, and in this position here. But there will be very little chance of finding the particle here because the wave function is going to 0, or here, or there will be basically no chance of finding the particle here because here the wave function is exactly 0. Okay, so this is giving us a probabilistic interpretation and telling you how likely is it that I find the particle in different positions in space. The last thing I want to mention in this mini lecture is the fact that all we know about the system we are looking at, let's say we are looking at an electron, we are looking at a molecule, everything is contained here in the wave function. So the wave function contains everything about the system we want to investigate. So the question is, how do we find things like energy, position, momentum, or position, or any other property of my system? So how do we find that? Well, that leads to the second central point, concept of quantum mechanics, which is the concept of physical quantities and operators. So this is the thing we're going to see in the next mini lecture, physical quantities and operators.